Hello everyone. In this video, let's discuss how to write a program to add digits. Given an integer num, repeatedly add all its digits until the result has only one digit and return it. Let's take an example. So here they are given the input value is 38. So what do we need to find? We have to find sum of the digits. 3 plus 8, the value is 11, which is not a single digit number. So we have to repeat the process again. That is 1 plus 1, the value is 2. 2 is a single digit number, so the output is 2. Let's take one more example. Here they have given the input value number is 0, so the output is 0. They have given one more follow-up that could you do it without any loop or recursion in big O of 1 runtime. So this problem can be solved with loop and without loop. So when we try to solve this problem with loop, the time complexity is log n. And the efficient approach can be solved with the time complexity of big O of 1. So first let's discuss how to solve with log n and then how to optimize this to big O of 1 we'll discuss now. So this question is purely based on the logic of finding sum of a digits. So I'll take a variable called sum and I'll initialize the value of the sum as 0. Now what I'm going to do is I'm going to check a condition. While num is greater than 0, I'll go inside, I'll find the sum of a digit. So what is the logic of finding sum of a digit? Int remainder equal to num modulus 10, then sum equal to sum plus remainder, and then num equal to num divided by 10. So this is the logic of finding sum of the digits. Now let's take the input value num as 38. So when I take the input value num as 38, 38 greater than 0, condition is true. If the condition is true, I'll go inside, I'll find sum of a digits. Okay, and I'll repeat the process. So here, after finding sum of a digit, I'll be getting my sum value as 11. But I should not stop this. Again, I have to find sum of the digit. For that, I'll be writing one more condition saying that or if sum value is greater than or equal to 10, I should go inside this loop. So when the value of this sum has to be assigned to the variable n, in the sense whenever the num value becomes 0 at that point of time, I have to assign the sum value back to num and I'll reinitialize the sum value as 0 because for 11 I have to find sum of a digits. Now let me trace this code so that you can understand how does this work. So according to OR, if any one condition satisfies, that is fine. So 38 greater than 0, condition true. I'll go in check whether my num value equal to 0, no. I'll find sum of a digits. 38 modulus 10, my remainder is 8. Then I'll find sum equal to sum plus remainder. So sum value is 0, 0 plus 8, which is 8. 0 plus 8, which is equal to 8. Then I'll go for num equal to num by 10. So num equal to 38, 38 divided by 10, my quotient value is 3. Then I'll go for the next iteration. 3 greater than 0? Yes, 3 is greater than 0. If the condition is true, I'll go and say num equal to 0? No. I'll find the remainder. So 3 modulus 10, the remainder is 3. Then I'll go for sum equal to sum plus remainder. Sum equal to 8 plus 3, my value is 11. Then I'll go and say num equal to num by 10. 3 by 10, the value of num is 0. Then I'll go for the next iteration. 0 greater than 0, condition false, which means we have calculated the sum of the digits. Now I have to check whether that is a single digit number or not. For that only I am checking one more condition. Sum value is greater than or equal to 10? Yes, because the sum value is 11. So I'll go inside. Now I have calculated sum of a digit. At that point of time, num value will be 0. So I'll be assigning my sum value to the variable num. Sum value is 11. That will be assigned to the variable num. Now num value is 11. Again I'll try to find sum of a digits for 11. So remainder equal to num value is 11 now. 11 modulus 10, my remainder is 1. Sum value is 0. Okay. So 0 plus remainder value is 1. 0 plus 1, the value is 1. Next, num equal to num divided by 10. Num value is 11. 11 divided by 10, the num value becomes 1. I'll go for the next iteration. 1 greater than 0? Yes. So I'll go inside. Num value equal to 0? No. So I'll find the remainder. 1 modulus 10, the remainder is 1. Sum equal to sum plus remainder. Sum value is 1. 1 plus 1, the value is equal to 2. Then I'll go for num equal to num by 10. So 1 divided by 10, the num value becomes 0. Then go for the next iteration. 0 greater than 0, condition becomes false. So which means we have calculated sum of a digits for the value called 11. Now check whether sum value is greater than 9. This is greater than or equal to 10 or not. So sum value is 2. 2 greater than or equal to 10, condition becomes false. Which means we have got sum of a digit which is a single digit number. So I'll come out of the loop and then I'll return a value called sum. Okay. Let's run the code now. It passes the test cases. Let's submit the code. Yes, it passes all the test cases, but it beats only 86.27%. The reason we have not solved with time complexity of big O of 1. They have asked us to solve it with big O of 1. We have solved it big O of log n. So how to solve this in big O of 1 time complexity? The logic is very simple. There is a mathematical concept called digit sum. With it we can solve this. Logic is very simple. If my input value is equal to 0, I can return the value called 0. Else, if the value divided by 9, if the remainder is equal to 0, we can say my answer is 9 only. Else, whatever you are getting as a remainder, that is your answer. So let's take an example 81. 81 modulus 9, my remainder is 0. So I can say 9 is my answer. 8 plus 1, 9. When I take 95, so 9 plus 5, the value is 14. 1 plus 4, the value is 5. So 94 divided by 9, the remainder is 5, which is not equal to 0. So I'll go for else part. 94 modulus 9, my remainder is 5, that is my answer. So this is the logic which helps us to solve the time complexity of big O of 1 time complexity. Let's run the code now. As it passes the test cases, let's submit the code. See, it beats 100%. That's all.